Okay guys, we're going to review solubility. Before I go over the questions on the review, I want to review with you guys the definitions of saturated, unsaturated, and supersaturated. Okay, so we'll start with unsaturated. Unsaturated basically means that if you have a solution and you're adding a solute to a solvent, that you can add more solute to the solvent. So there's room for more to dissolve in the solution. Okay, so you can add, we'll say, more solute can be dissolved into a solution or in a solution. Right? I mean, we can add as much as we want and it'll just settle at the bottom. But unsaturated means you can add more and it will still mix. Okay, it won't settle to the bottom. Saturated means you just got to the point where no more will dissolve. No more solvent. Okay, and then supersaturated means we have way more solute. More solute than can dissolve. And remember, this is at a specific temperature. Okay, the more the temperature increases, the more solute you can dissolve in the solution. Okay, and then let's also remind ourselves what solubility is. Solubility is how easily something dissolves into something else, okay? How easily something dissolves. And for liquids and solids, we know that increasing the temperature is going to increase the solubility, okay, making it easier to dissolve. You can get more of the solute in there as you increase the temperature, okay, for solids and liquids. Gases is just the opposite. Remember that, okay? As the temperature increases for gases, the solubility decreases. So if you want to get a lot of gas into something, like our sodas, right, our Cokes, we need to add pressure. Okay, we want to lower the temperature. That's why we like our sodas nice and cold, refrigerated. That's how you're going to get the most fizz in your soft drink. Okay, when you let them out and they warm up, they lose their the CO2 that was inside of the liquid. Okay, you reduced the solubility of the gas by letting the temperature get warmer. All right, I've got my handy dandy little solubility curve chart here. We're going to answer the following questions. Are the following solutions unsaturated, saturated, or supersaturated? 45 grams of NaNO3 and 100 grams of water at 30 degrees Celsius. So let's come over here to 30 degrees. Okay, then we want to find NaNO3, which is way up here. Okay, so right here is the solubility point. Okay, and we're at like 95 grams. At 30 degrees temperature. So if we add 45 is less than 90, right? So that would be unsaturated. That means we can get another 45 in there. Actually, almost 50. So we would call that unsaturated. Okay, 60 grams of KClO3 at 60 degrees Celsius. So let's come over to 60 degrees. KClO3 is this one right here. Okay, so the solubility point would be, if I come across here, about 26 grams. Okay, and they want to know if we add 60 grams, is that going to be unsaturated, saturated, or supersaturated? Well, 60 is way more than 26 grams, so that would be supersaturated. Okay, 65 grams of NH4Cl at 80 degrees Celsius. 80 is here. NH4Cl is right here. So the saturation point of this one, I'm in screen here, is about 65 grams. Okay, and that's what they asked for, so that would be saturated. It's right there on the exact line. That would be the saturation point. 12 grams of NH3 at 90. Here's 90. NH3 is right here, this curve going down. When the curve goes down, that tells us it must be a gas, okay? So at 90 degrees, the saturation point of NH3 is about 10, it looks like, right? 90 degrees, NH3, come over here to 10 grams. So if we add 12, that's going to be supersaturated. Just a little bit, okay? But it's going to be more than what the salt solution can hold, and so it will settle, some will settle, okay? How many grams of sodium chloride are required to saturate 100 grams of water at 100 degrees Celsius? I'm going to come over here to 100 degrees Celsius. NaCl is right here, this line right here. It's kind of hard to see. So how many grams would this be? Oh, I'm going to call that about 40. We'll just say 40. Okay, 40 grams. We're not going to split hairs here. 40 grams. How many grams of NaNO3 are required to saturate 100 grams of water at 90 degrees? Here's 90 degrees, and we are looking for NaNO3, which is this one way up here. So at 90 degrees, NaNO3 goes off the chart, so we can extend our lines. Okay, if this is 150, we could call that about 155. So that's what we'll put, 155 grams. How many grams of Ki will saturate water at 20 degrees? So 20 degrees, and then Ki is way up here. Okay, so about 145, 146. At what temperature would 25 grams of potassium chlorate dissolve? Okay, so now we're kind of going the other direction. 25 grams of KClO3 right here. So we're going to come across to where 25 grams and KClO3 meet. I'm sorry, let me change colors here. Okay, they said 25 grams, which is between 20 and 30. And I'm going to extend this line over to where it intersects my KClO3 curve. And that's going to be right at about 60 degrees. At what temperature would 55 grams of NH4Cl dissolve? Same concept. So we're going to go up to 55 grams right here. I'm going to see where it intersects the KClO3. Was that what it was? No, NH4Cl. NH4Cl is right here. Okay, so I'm going to extend this line out to where these two intersect now. And that's, I'm going to come down, that's also 60 degrees. Okay, and that is solubility. If you guys have questions, let me know.